Okay, so on this bell work exercise, we're going to look at various circle theorems. And if we look at problem number one, if I bring up problem number one, notice that we have a triangle that's inscribed in a half circle. And if it's inscribed in a half circle, then that tells me that since a half circle is, since this is 180 degrees halfway around, right? If a circle is 360 degrees, then half a circle is 180 degrees. So that means that this inscribed angle opposite that arc has to be 90 degrees. Let me change colors here just so we can have an idea. This angle here, this right angle, is the inscribed angle to this arc here, which is 180 degrees. And the formula that we learned says that the measure of an inscribed angle is 1/2 of its intercepted arc. So the answer would be 90. Okay. Let's take a look at problem number two. On problem number two, it says to find the value of the angle marked x. And this is going to be pretty much the same concept. At first, this may appear to be a little tricky. Some students think there's not enough information. But notice that this angle here, designated as x degrees, that angle inscribes this arc here. But the 56-degree angle also is an inscribed angle to the same arc. Well, that means that these two angles have to be equal, right? Because they intersect the same arc. In other words, if this inscribed angle is 56, then if you double 56, you're going to get 112. So that means the arc is 112 degrees. And since x intercepts that arc, it's going to be half of the 112 degrees, which makes that 56. So the answer for number two, to make a long story short, is 56. Problem number three. Well, we're back to the same situation, right? We're trying to find the value for x. And again, let's see, we have a central angle here that's 100. And remember that a central angle is equal to its intercepted arc, which means the arc measure, if you go from this point all the way to here, that's going to be also equal to 100 because the central angle has the same measure as its arc. But this angle here is inscribed, right? So it's half of the 100, which would make that answer 50. Problem number four. On this one, we have a circle with several different radii, and basically we're trying to figure out the measure of arc GH. So let's take a look at this one. Arc GH is the measure from here to here. And it looks to me like if you go all the way from K to H, in other words, if you go from here all the way around to here, looks to me like that is a half circle or a semicircle. And how many degrees are in a semicircle? Well, we said earlier that half of a circle, right, would be 1/2 of 360 degrees. So that tells me that x plus 116 plus x plus 76 has to equal a total of 180 degrees, right? Because there's 180 degrees in a half circle. And if I add these up, x plus x is 2x. And then I'm going to add, what am I going to add here? 116 plus 76. That's going to be, I believe, 192. going to set that equal to 180. And I'm going to subtract 192 from both sides, and 180 minus 192 is going to be negative 12. If I divide by 2, that means x is equal to negative 6. If x is equal to negative 6, then this x is negative 6, and negative 6 plus 76 would give you 70. So here's an extension of that. If I figured out that this arc here is 70 degrees, then what would this arc on this side have to be? Well, we know that those two arcs have to total 180, so we know that arc GK has to be 110. Now, they did not ask for that, but we thought, I thought we might as well discuss it. But the answer to the problem here, as given, is 70 degrees. Number 5, determine the value of x in the diagram. In this diagram, we have two intersecting chords. And the formula for intersecting chords is not too bad. We just have to cross multiply, basically. I'm going to multiply this 12 times 6. And let's see, 12 times 6 is going to have to equal 8 times x. And 12 times 6 is 72. So 72 ends up being 8x. And if we divide by 8, 72 divided by 8 is positive 9. And x happens to represent the length of this piece of cord here. So I know that that has to be 9. Okay. Problem number 6. This time we have two chords intersecting, and they're asking us to figure out the measure of the angle on the outside there. And notice that these chords do not cross in the center of the circle. If they crossed in the center of the circle, then I could just say, well, 138 is the average of 50 plus x, of 50 and x. And so unfortunately I can't do that, right? Because we're off center here. So how do we solve it? Well, first of all, we know that if this is 138 here, we know that this little angle here has to be the supplement of that, right? There's 180 degrees in a straight line, and 180 minus 138 would leave me 42. So this little angle here is 42 degrees. So to find x, I'm going to say that x plus 50, x degrees plus 50 degrees divided by 2 is equal to the angle, and we figured out that that's 42. And I could rewrite the 42 as a 42 over 1. That way I have a fraction on both sides. And now I'm just going to cross multiply. I'm going to multiply 2 times 42, which gives me 84. And that's going to equal 1 times x plus 50, which is x plus 50. Now to get x by itself, I would just subtract 50 from both sides. And 84 minus 50 is going to be 34. So that would be our answer for this problem. Problem number 7. On problem number 7, I have a circle with two tangent lines, or in this case, two tangent rays coming from the same external point. And I want to figure out what is x. Well, the formula says that if you have a situation like this, the outer arc, which goes from here to here, minus the inner arc divided by 2 gives you this angle. So I'm going to say 12x plus 3 minus 5x. Well, 12x plus 3 minus 5x is going to be 7x plus 3. And if I divide that by 2, that has to be equal to the angle, which is 75. And again, I can write this as 75 over 1. When I cross multiply, that would give me 7x plus 3 is equal to 150. 150 is 2 times 75. And when I subtract 3 from both sides, that would give me 7x is equal to 147. And it looks to me like 7 would go into 147 21 times. So that would be the answer to that problem. Now you may be wondering, how in the world did he know to do that? Well, I've learned these formulas over many years of practice. And hopefully you're starting to figure out how to solve these types of problems. If not, definitely go back to the lesson and watch the videos.